Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk about some questions similar to what we're seeing on our test, because we have a test coming up over properties of exponents. So I want to take a few minutes to kind of talk about some sample problems in preparation of being in the best position to do well on our test. So let's go ahead and get started, all right? Let's take a look at this question. Which expression is equivalent to this here? So what we want to do is we want to apply our properties of exponents to simplify this expression. All right, so if we was to do this, what you notice is break it down piece by piece. Let's just focus on the numerator first. All right, notice this is power of a product. So we're taking that outside exponent 3 and we're going to raise it to each power inside the parentheses. So this is the same thing as saying 14 times 5 to the 14 to the 5 times 3 power, which is 14 to the 15th power. And then this is saying 5 to the 8 times 3 power, which is going to be 5 to the 24th power, over 14 to the 2nd power. Now, if you notice, these two have the same base. So since they have the same base, you can apply the quotient of powers property to 14 to the 15th power over 14 to the 2nd power. And so with the quotient of powers property, you want to subtract. So if we subtract 15 minus 2, you get 14 to the 13th power. All right. 14 to the 13th power times 5 to the 24th power, which will be D. Okay. Let's look at this one. Which expression is equivalent to 36 to the negative 6th power? All right, so let's see which one of these will give us 36 to the negative 6th power. If you look at A, 36 to the negative 9th over 36 to the negative 3rd, this is quotient of powers property. So we subtract our exponents. So this would be negative 9 minus negative 3, which gives us 36 to the negative 6th power. So it looks like A could be the answer, but let's double check the other answer choices. So B, 36 to the 0 power times 36 to the 6th power, that's product of powers. You're going to add those exponents together. That'll give you 36 to the 6th power. If you look at C, all right, 9 to the negative 6 over 4 to the 6 raised to the negative 1st power. You're going to take that, that's power product. You're going to take that outside term and you're going to raise it to each term inside the parentheses. So this is going to say, this is going to be negative 6 times negative 1 and 6 times negative 1, which will give you 9 to the 6th power over 4 to the negative 6th power. And then for the last one, product of powers, you're going to add those exponents together. So you're going to do negative 1 plus 7, which will give you 36 to the 6th power. So the one that will be our answer here will be A, because that's equivalent to 36 to the negative 6th power. All right, let's look at this question. Which expression is equivalent to 8 to the 5th times 3 to the 7th raised to the 0? This is product of powers. Power of a product, sorry. So you're going to take that outside exponent 0. You're going to raise it to each term inside of your parentheses. So this is the same thing as saying 8 to the 5th raised to the 0 power. So you're going to multiply 5 times 0, which is 0. 3 to the 7th raised to the 0. So you're going to multiply 7 times 0, which is 0. Then you have the 0 exponent property. Any number raised to the 0 power is 1. Okay, so 8 to the 0 power is 1. 3 to the 0 power is 1, and 1 times 1 is 1. So your answer would be B. Now let's look at this one. It says, which of the following is a true statement? So we got to apply our properties of exponents. If you look at A, this is power of a power. So you're going to multiply 1 times 9, which is 9. And this is product of powers, so you're going to add 5 plus 5, which is 10. And notice 7 to the 9th is not the same as 7 to the 10th, so that's not a true statement there. If you look at B, look at your denominator, that's power of a power. So you're going to multiply 2 times 6, which is going to give you 12. And then that gives you power of a product. Quotient of a product. So then you're going to do 13 minus 12, which gives you 1. So that'll be y to the 1st power, or just y. And then on the right side of the equal sign, you got product of powers. So you're going to add negative 10 plus 9, which is going to give you negative 1. And as you can see, y is not the same as y to the negative 1st power. And then for C, product of powers, you're going to add those exponents together. So 4 plus negative 6 is going to give you negative 2. All right, and then for the right side, you're gonna, in your numerator, you're gonna add, because it's product of powers, 1 plus 3 is 4, so that's b to the 4th over b to the 6th. Then you have quotient of powers, so you're gonna do b to the 4th. You're gonna do 4 minus 6, which gives you -2. So b to the -2nd is the same as b to the -2nd. So C would be the answer for that. All right, for this question here, which gives you a value of 1. So let's take a look. All right, product of powers, so you're going to add. So we do -6 plus 5 is going to give you 7 to the -1st power. This is a quotient of powers, so you're going to subtract your exponents. So 3 minus 2 gives you 1, so that gives you 10 to the 1st power, or just 10. C, your numerator, you're going to do power of a power, so you're going to do 4 times 2, which is 8. So that's 5 to the 8th over 5 to the 8th, and then you have a quotient of powers property. So then you're going to subtract 8 minus 8, which gives you 5 to the 0th power. For D, you're going to do product of powers. You're going to add 2 and 5, which is 7. So 3 to the 7th over 3 to the 10th. Then you got quotient of powers property. You do 7 minus 10. You're going to get 3 to the -3rd power. All right. A lot of people would get B confused because it says what has a value of 1. 10 to the 1st power. That's just the power. This is saying what gives you a value of 1, not the exponent of 1. Go to C. Think about the 0 exponent property. Any number raised to the 0 power is 1. So therefore 5 to the 0 power is 1. So your answer should be C. All right. Look at this one. Which of the following represents the value of x? The missing exponent need to make the equation true. So we got to see which one of these will make this a true statement. So let's go ahead and apply our properties of exponents first. So the numerator is power of a power. So you're going to multiply 5 times 4, which is 20. So this is c to the 20th over c to the x. And then you're going to add -3 plus 2. So it's going to be -3 plus 2 is going to give you -1. So you have 20 over x. So you're going to do quotient of power. So you're going to subtract. So it's going to be c to the 20th minus x power, which equals to c to the -1st power. Notice they both have the same base. So since they both have the same base, you can ignore the bases and just focus on the exponent to solve for x. So we could just view this as saying 20 minus x equals -1. So you see what we did here? All we did was we ignored the base. Now we just solve for x like we would a normal equation. You want to get x by itself. So you do the inverse operation. Subtract 20 on both sides. You get -x equals -21. But we don't want a negative variable, we want a positive variable. So what we need to do is divide both sides by -1. And we see that x equals 21. So your answer would be C. So what that tells us is that 21 would be the value for x in this particular expression that will make the statement true. All right, let's look at this one. Determine if the statement is true or false. So let's take a look. Let's look on the left side. All right, we got power of a power and then product of power. So power of a power, -7 times 2 is going to give you -14. And then -14 plus 2 is going to give you -12. If we add this here, -3 plus 4 gives you 1. So -14 plus 2, which is -12, -3 plus 4, which is 1. And if you notice, 7 to the -12 is not the same as 7 to the 1st. So this will be false. All right. Similar to the previous problem, we want to see what number we can put for x that will make this true. We want to apply our product of properties of exponents. So this right here on the left side is quotient of powers. So you're going to subtract. So you're going to do 10 minus 14. And this is power of a power, so you're going to multiply. So you're going to do 2 times x. So 10 minus 14 is going to give you -4. 2 times x is 2x. Notice they have the same base. So we could just ignore n for right now and focus on just the exponent. -4 equals 2x. And just solve for x like we would a normal equation. So to isolate x, we're going to do the inverse operation. So the inverse of multiplication is division. And so we do -4 divided by 2, you get -2. So -2 will be our answer, which is B. So what that tells us is if we substitute x for -2, this will make this particular equation true. All right, and then for this one, I want to simplify. Basically, what you want to do with this is break this down piece by piece. Like, look at this, it's saying 20 over 5 times d to the third over d to the second times f to the second over f times g to the eighth over g to the third. Notice 20 over 5 is numeric, so we can actually simplify that. There's no exponent to those. So we can actually do 20 divided by 5, which is 4, okay? D to the third over D to the second, quotient of powers, you're going to subtract 3 minus 2. This is also quotient of powers. You're going to do 2 minus 1. And this is also quotient of powers, so you're going to do 8 minus 3. All right? So 4, all right, and then 3 minus 2 is 1. So D to the first or D, F to the first or F, and then G to the 5, which will give you C. All right? And then it says this is equivalent to x to the n power. Basically, this is saying simplify this expression, basically. And when we simplify, what do we get? So notice, you have power of a power and product of powers. So if you have power of a power, 2 times negative 3 is going to give you negative 6. All right? And if you do x to the 10th times x to the negative 6, you're doing product of powers, you're going to add. So 10 plus negative 6, which is going to give you 4. So A would be the answer for this particular question. All right? And so basically what we're trying to do is look at some sample problems that you will see on the upcoming test, and we'll apply our properties of exponents. So just to recap on properties of exponents, product of powers, when you multiply with the same base, you're going to add those exponents together. All right? Power of a power. When you have an exponent raised to a power, you're going to multiply those exponents together. Quotient of powers, meaning when you're dividing with the same base, you're going to subtract your exponents. Power of a product, when you have like multiple terms inside of the parentheses and you have an outside exponent, you're going to take that outside exponent and you're going to raise it to each term inside of your parentheses. So this is just an overview and, you know, looking over some sample problems, applying our properties of exponents in preparation for our upcoming tests. So I hope this helps.